Good morning, students. Hope you are all doing well. Today we'll go for one of the interesting topics called circles. So, about the circles, first of all, we'll discuss about the definition, and from the definition, we'll try to derive the equation of the circle, and that equation we'll try to analyze out actually. Then, later, we'll extend our discussion by deriving the different forms of equation of circle, like as diameter endpoint circle equation or equation of circle in parametric form. Like this, we are having different forms of circle equation that we will discuss, and of course we will derive also. So let us start with the definition. What is the definition of a circle? The definition is, it is the locus of a point in a plane whose distance from a fixed point is always constant. So this is what the definition of the circle. Now in this locus definition, there are two things are there that we have to concentrate. One is the fixed point. This fixed point is called as the center of the circle. And the distance which is constant, this constant distance is called as the radius of the circle. So if I denote that center with C and radius with R, this radius should be greater than or equal to 0. If it is greater than or equal to 0, if the radius is greater than or equal to 0, then that circle represents a real circle. And we are going to discuss about the real circle related properties and its related problems, of course, we are going to solve. So let us derive the equation of the circle from this definition. So here, obviously, we have to take the plane, xy plane. Since circle is a two-dimensional figure, so I have taken that xy plane. This is what my y-axis, this is what my x-axis, and this is what my origin. So from the definition, what we are observing is that we have to take the center which is fixed point. Say somewhere here I have taken a center C whose coordinates are a comma b. C is a center whose coordinates are a comma b, which is fixed. And somewhere a locus point is P whose coordinates are x comma y. So this point P is a moving point. Now from this moving point P or locus point, the distance is always constant. So when it is moving from this P to this C, the distance is always constant, and that constant distance is equal to radius. So this is what the definition figuratively that I try to explain. Now from this figure, what we are trying to understand is the distance from P to C is always equal to radius. So this is what my algebraic expression of the locus. Now when I derive this, when I simplify this one, PC square is equal to R square, squaring on both sides, I got this one. And PC is nothing but the distance from P to C. So what is the distance from P to C, where C is A comma B and P is X comma Y. So what is the distance between P and C? It is equal to X minus A whole square plus Y minus B whole square. Okay, is equal to PC square, this is equal to R square. Now upon simplifying this equation, we will get the form like this: x square plus y square minus 2ax minus 2by plus a square plus b square is equal to r square. So this is what about the simplified form of the equation. Now from this equation, certain properties that we can observe. First thing is that the equation of circle is a second degree equation, unlike the straight line equation, which is always linear equation, whereas here the circle equation is a second degree equation. So the first property which we are observing is, okay, the equation of circle is second degree equation. second property which we are clearly observing is the coefficient of x square is always equal to the coefficient of y square. This was the second property from the equation that we are observing. And the third property is the coefficient of xy, we don't have xy term, observe that, is equal to 0. So these are the three important properties that we observed from the equation which we derived.